Hi, I'm Iveta from Oxylabs. If you're watching this video, you're probably interested in working or are already working with large language models, or in other words, LLMs. In this video, we'll explore the differences between the main terms such as training and fine-tuning, and we'll take a look at some primary data sources used for training or fine-tuning LLMs. Let's start from the beginning. Training, fine-tuning, and RAG. What are the differences between these main terms? Let's start with the term training. Training is the foundation. In other words, it lays the groundwork for creating smart language models. Training is the beginning process where a general language model is built using vast, diverse data to understand language broadly. Imagine if you're teaching a child how to speak and understand language. So, training involves providing the child with books, conversation examples, and any other relevant material and lessons to help them understand how the language works in general. Then there's fine-tuning. Fine-tuning hones the model for specific tasks, or in other words, it helps the model to become more skilled in a particular area. Fine-tuning involves adapting a pre-trained model for specific tasks or domains using a smaller, targeted data set, thereby making it more specialized and effective in those areas. So, if your child is now grown up and knows how to speak already, and you want them to excel in legal writing, for example, you can give them a smaller set of materials focused just on this topic. Lastly, we have RAG, Retrieval Augmented Generation, which is a new method for enhancing LLMs by retrieving relevant external data in real time during text generation. In simple terms, we could call RAG a smart lookup while answering. It ensures more accurate, up-to-date responses while leveraging the model's general knowledge. Returning to our reference, the RAG method would be akin to our child Googling facts with one hand while doing homework with the other. Both of these activities would be done simultaneously. At this point, you might be thinking, whether in the stage of training or fine-tuning the LLM, one needs vast and diverse data to help the model capture nuanced, domain-specific knowledge. Why does the type of data matter? The better and more relevant your data, the better your model will perform. But what data sources can you use for training or fine-tuning LLMs to ensure they perform well? Let's explore the three main types. The first one is licensed data. This type of data is protected by copyright or other intellectual property rights. What's important is that you need permission to use this data. And even if the owner grants you the rights to use data through a license agreement, the licensed data may have restrictions. The second one is data covered by public copyright licenses. The data is available for anyone to access, use, modify, and share as long as you follow the license rules. A few examples. Wikipedia provides both structured and unstructured data, which is licensed under a Creative Commons license and can be used for research and development purposes. Common Crawl provides a vast collection of web data collected through web crawling, which can be processed to suit specific model requirements. Hugging Face, a community-driven platform offering ready-to-use datasets. It supports multiple data types, text, images, audio, and integrates with ML frameworks. The Pile offers a vast, high-quality collection of diverse data types, including academic papers, web pages, books, and code. The third one is publicly available data. Publicly available data refers to any information that can be found online for free without requiring a login or subscription. But here's the important part. Just because it's publicly available, it doesn't mean you can legally use it without double-checking the rules. A good rule of thumb would be to remember that all licensed public data is publicly available, but not all public data is licensed for use. A few examples of publicly available data would include e-commerce product listings, public product descriptions, reviews, and pricing information for marketplaces like Amazon, eBay, and similar. News sites and articles, publicly accessible articles and reports from media outlets such as the BBC, CNN, etc. WHO data, classified as both publicly available and data under a public copyright license. It is accessible to the general public without restrictions and is structured for easy use. So now that you know how to train or fine-tune your LLM model, the only thing you need to do is gather the data. How can you do it? Easy. You can use web scraping tools. Luckily, Oxylabs can offer a web scraper API, an all-in-one web data collection platform that covers every stage of web scraping. If you want to find out more about acquiring high-quality web data for LLM fine-tuning, you can find an in-depth white paper on this topic in the description. Thanks for tuning in! If you have any questions or would like to share your own experiences with training or fine-tuning LLMs, comment down below and we'll be sure to check them out. If you've encountered any problems with our products, email support@oxylabs.io or contact us via the live chat on our homepage. Also, consider joining our Discord community where we discuss all things web scraping. Thank you for watching and see you next time!